Did I say 47? I meant 27. Yeah, I meant 27. 27's got a nice trick to it. When we get into this one, if you look at what you have, you've got sine squared, a sine, and a constant. It just so happens that you've got a number in front of the sine squared, you've got a 1 on the other side. First thing I'm going to do, yeah. Not necessarily, because we're solving for the angle, so I'm going to keep the x's in these, because we're going to keep them there.
Okay, but that one next to the sign, like attached to it, that was the one that you said it doesn't really
That's what I'm, yeah, that's kind of what we're doing, like what you just redid on that quiz there. When we're solving equations, I tend to try to force myself to remember to put the variable in there. That way I know where I'm going with it. With the other ones, I'm just simplifying. I don't really mess with them. So in here, first thing I'm going to do is going to get the 1 to the left side. So 2 sine squared x minus sine squared minus 1 is 0. Here's a trick that we use in math. The trick we use in math at this point is called U substitution. U substitution is nothing more than letting U equal sine of x. The reason why I'm letting U equal sine of x is because right now sine squared of x and sine of x is a lot of stuff. So what I'm doing here is everywhere I see a sine of x, I'm going to replace it with u. So I get this. 2u squared minus u minus 1 is 0. Now it looks something a little bit easier to work with. I can factor it now. What's 2 times negative 1? What times what's negative 2? But if I add it together, I get negative 1.
Negative 2 and 1.
Negative 2 and 1. So I get 2u squared minus 2u plus 1u minus 1 is 0. I'm setting this up for factoring by grouping. If I factor by group, I'm going to take my GCFs. U minus 1. Take out a 1. And now I'm left with 2u plus 1 and u minus 1 equals 0. All the while, u is equal to what? Sine of x. So at this point, now I can rewrite it as 2 sine of x plus 1. Does everybody agree I have to set both of these equal to 0? I'm just going to do that right off the bat. The trick here is using this u substitution. You don't need it. You could have factored it with the grouping wise with the sine of x in there, but there's just a lot more letters and a lot more other stuff to get lost within. U substitution is a huge trick that you will see over and over and over and over again in pre-calc and especially in calculus. Use it all the time. It's very easy. Let something small stand for something messy. Something easier to work with to equal something that's messy. So here my two values are x is going to have the inverse sine of negative 1/2, and x is going to have the inverse sine of 1. Everybody okay with that shortcut? What triangle am I working with if I have sine of 1/2? Am I 30/60 or am I 40? 30/60s? Which one is the half? The 30.
30.
The 30. And what is 30 in terms of radians again? Pi over 6, very good. So I'm looking for a negative 1/2 in a sine value. What quadrants are sine negative, or is sine negative? 4 and 3. So if my reference angle is pi over 6, in the third quadrant it is going to be how much? 7 pi over 6, very good. And in the fourth quadrant it'll be?
Very good, Doug. You're doing just fine. You got the work.
He's bang.
I knew that. I knew that reference. I've seen that movie.
Just making sure not everybody does.
I know. I know. It's a movie that both people just
Just kind of mumble a whole lot, you don't understand what they're saying. It ain't like that.
Now, was this a general solution problem or was this an interval problem? I think this was a general problem. So what you're thinking about now is there's no commonality of adding or subtracting pi to get me back to the same point for either one of those. So I'm just going to tack on a 2 pi n to both of them. And then go to the other one. Where does sine have a value equal to 1?
In your calculator.
It is in your calculator, yes, but where? Where's sine equal to 1? 45 would be, sine would be root, be 1 over root 2.
Yeah. Tab them.
Isn't that sine equal to 1?
Technically, yeah.
So what's that measure? 0. So this one has a value of 0. And then again, I'm talking about general solution here, so what do I have to tack onto that? Plus 2 pi n. What were you going to say? Oh, I'm sorry. You got the. Well, yeah. Hi, good morning. How's that? Yes, sir.
I put that into the calculator and it got like 1.57 for.
Multiply it by 2. If you do that in the calculator, you multiply it by 2, you're going to find out you got pi. Yeah. You see what I'm saying? Yeah, you would get, it should be pi over 2. I don't know why it's 0. Oops. Yeah, it should be pi over 2.
Alright.
The trick here is, guys, whenever you see it equaling 1 or equaling 0, think about your quadrantals, especially for sine and cosine. If it's 1 or 0 for tangent, then it's something different. Okay? What else do you want to look at in that group?
25.
Which one?
25.
25? Okay. With these two terms, what do they have in common? They both have a cosine, right? So let's factor cosine out. And I get that, don't I? I have two terms equal to 0. Cosine of x. Sine of x. Now, where is cosine equal to 0? Look about your ordered pairs. That's 0. That's 1, 0. Here's 0, 1. Here's 0, negative 1. Here's negative 1, 0. Where is cosine? 0. And 0, 1, what is that? Pi over 2. So cosine is 0 at pi over 2. And where else? 3 pi over 2. Now, this case, these guys are only pi apart from one another, correct? So no matter what, if I start at pi over 2 and I add some pi interval, will I always end up at the next one? So your general solution for this problem would just be pi over 2 plus pi n. And where do I have a sine value equal to 2?
Nowhere.
Nowhere. So this is an undefined spot, so this isn't, that one doesn't happen. There's no solution to that part. That'll happen sometimes. Does that make sense then, Doug? Yes, sir.
Can you do 40?
Sure. Are there other ones in the general solution bit?
6.
If I factored out a cosine in 25, what do you have to think I have to factor out of in 26? Cosine. So right off the bat, when you factor out cosine, you have cosine of x times root 2 sine of x minus 1 is 0. So cosine of x is 0, and sine of x is 1 over root 2. Everybody okay with me just shortcutting it to that? We just did cosine of x equaling 0. It was at pi over 2 plus pi n. We just did that from the previous problems. We knew it was going to be pi over 2, 3 pi over 2, and so on and so forth. On the other one, what triangle am I looking at to get 1 over root 2? 45. So I know it's going to be this, the x value is going to be pi over 4. This 45-degree angle is always going to be sine value. That's going to be 1 over root 2. Now, when I'm thinking about sine being positive, my reference angle is pi over 4. What other quadrant is sine positive in? 1 and 2. So this one is at 3 pi over 4. Is there always going to be some commonality that I can add to those to always get to the other one? So in this case, again, I'm going to tack on plus 2 pi n. And that's how that one works. Okay. When you see two terms separated by subtraction, they're not squared, always look for your GCFs to factor that out so you can get to set it up that way. It's a very nice shortcut to go through it. On the other side, when we're working with equations within the interval, this is when we're just looking to list out all possible solutions. And in 40, there's a trick. Oops. What's that? There's always a trick. What's sine times secant? It's tangent. So you get tangent squared of x is tangent squared. I meant it's tangent squared of x is tangent of x. Excuse me. Yeah. You divide out by the tangent of x to move it back. Tangent squared divided by tangent is just tangent. And then what triangle is going to give me a tangent equal to 1? 45 is again. Okay. So that means at pi over 4 gives me a positive 1 for my tangent. Now I'm only looking for the positive value. What other quadrant is tangent positive in? So that is at, good. Your two solutions are pi over 4 and 5 pi over 4. And that's it. And we're within one revolution, so you have to tack anything out in this case. Okay. All right. The other one that you had to use your calculator with was 36. Did you guys get that one okay?
Yeah.
Yeah, where you got tangent equal to a half, and then you got 0.4 something.
I got 26.
Keep it in radians though. Remember, when you're dealing with your radians, the way that you know that you're going to be in radians is the interval they gave us was between 0 and 2 pi. That's implying that you're going to be in radians. If it said between 0 and 360, then you'd switch it to degrees. Okay. If you got that 22 and change, I think that's about what it worked out to be. But you guys get that one okay? Yeah, right.
So just 0.46 would be your answer? Or?
Yes, that 0.46, remember, since it's a positive 1/2, that means it's got to be in the first quadrant. And then the other value that gives you a positive tangent is in the third quadrant. So these 2 points themselves are just pi away from one another.
So 0.46 plus
Yeah,
2 and, or plus 99?
you're within one interval, so your two answers would be 0.46 and 0.46 plus pi. Okay? And that's how you just get to that third quadrant. You don't have to list out any plus
There's no
n's.
n on that one?
Nope, because it's within one revolution. Whenever you see that interval, it means you're in a revolution.
Oh, I didn't see that on
Viva la revolution! No, because it was in a revolution. Let's do some tougher ones. I want to look at numbers fall on this side.
Yeah, I remember when I wore those back in second grade.
Let's take a look at number 12 here. I'm going to pass this out to you. I got some copies of it. We don't have to worry about writing it all out. Give me a second. I'll look at it.
What government has they, because the citizens cannot buy a cheap
No, we're turning this up tonight. This is where it's going to get interesting.
Maybe more like
So what I want to look at here is on the A side, guys, I want to take a look at on the A side. I want to look at number 12. This is where things start to get a little interesting. Yep, as they always do. Okay? We have enough?
I think so.
Story of my life.
Story of my life.
So let's see where we're at here. I've got 2 sine squared equals 2 plus cosine. In this scenario, there are 2 different trig functions going on here. Also, I want you to notice that there's a squared term and a non-squared term. When you see 2 different trig functions going on, one of them is squared and the other one is not, your idea here is to write them into the same trig function. Your idea then is to rewrite them into the lesser degree trig function. Which of these 2 has the smaller degree, sine squared or cosine? Cosine.
Cosine.
So what I'm going to do here is use some substitution, knowing that sine squared is equal to what? 1 minus cosine squared. Okay? Here's what I do. I take 2 times 1 minus cosine squared of x equals 2 plus cosine of x. Distribute. And just like before, I'm going to try to get one side equal to 0 by moving everything else around. Now, when we did this before, whenever we had the highest degree, we always wanted to make the highest degree part positive. So I'm going to move everything from the left to the right. Yeah, and in this case it does work like that. Not always will it be that like that. Okay. Again, I want to move this guy over to the right because he's negative right now. So I'm going to subtract 2, add 2 cosine squared x. So I'm going to get 0 equals 2 cosine squared x plus cosine of x. And like Paul said, the constant values of 2 drop out. You get 2 minus 2. Everybody okay with that? Now I'm back to a simple factoring problem. What's the GCF going on here? Cosine. So I factor out a cosine, I'm left with, excuse me, 2 cosine x plus 1. And now I can set both of those terms equal to 0. Oops. So I have cosine of x equals 0, and cosine of x is going to equal negative 1/2. Everybody okay with me just moving that stuff around right off the bat? 2 cosine x plus 1 equals 0. Subtract 1 divided by 2. That's where I get that. Now I have to find x for 2 different parts. We've done cosine of x is equal to 0. Where was that located again? So this was pi over 2 and 3 pi over 2. And now we figure out about cosine of negative 1/2. Which triangle am I in? Yes, ma'am.
Why did you solve for 0 on the other?
What I did here is I shortcut it. Subtract 1, divide by 2.
Oh, you just leave cosine.
Yeah. Because we know our next step is that x is going to equal the inverse cosine of a negative half, so that's why.
So you just.
Yeah, I just left it. So here, we have negative 1/2. Everybody agrees that's the 30, 60, 90. Which one of them is the 1/2? It's at the 60. In radians, then it is pi over 3. Good. So our reference angle is pi over 3. Cosine's negative in which two quadrants then? 2 and 3. 2 and 3. So if the reference angle is pi over 3, in the second quadrant it is 2 pi over 3. Very good. And then it will be 4 pi over 3. I believe the instructions on this problem was within 1 revolution, and I'm done. Okay? Not so bad. It's a little trick that occurs when you have to do some of these. It's a little trick. $13, same basic idea. I have a secant squared, tangent squared. One of those I can write in terms of the other relatively easily. You want to rewrite secant? Secant is what? Tangent squared plus 1. Very good. So what I would do here is rewrite this out as 2 times tangent squared plus 1 Good. At this point here, does everybody see that it becomes 3 tangent squared x? Open up. What do you do? Cry? Cry is not an option. There's no crying in algebra. You can pound. Yes, that's fine. And you guys can finish that out. The trick here is you want to write them in terms of one another if possible. It does happen. It does happen where you need to write them in terms of one another. Could you have done tangent squared was secant squared minus 1 and gotten the same basic idea? Yeah. At the very end, when you go to solve that out, remember when I think there was a problem in the homework where you had secant squared was 4 over 3 or something like that, and we had inverse it? You'd have to do that at the very end. You'll get the same result, but it goes through that way. What is one thing you have to remind yourself about to do at this point here when you take the square root? And why do you do that? Because the square root sucks. Right. On this one that you have in front of you now, that 14.4a side, I'd like you to go 9 through 18. Okay? 9 through 18. 10 problems.
Thanks. On the same side though.
Yeah, the 14a. Because the other side is the b stuff. The b stuff has a lot more of the inverse to it. We'll look at some of that inverse stuff tomorrow. Okay? We'll look at a little bit of that tomorrow, and then build into 14.5. The way that I have it planned out, you might have noticed this on the board. We're going to finish out the inverse junk tomorrow in 14.4, maybe start 14.5. We'll do 14.5 for about a day and a half. Friday we have our half day, which means we won't get really anything done. So we'll start doing some reviewing here between Friday and Monday. We'll test out a chapter 14 next Tuesday. Yes, sir?
What are we gonna do Wednesday?
16. Start chapter 10. Why? Did you think we were gonna have like a fun day or something?
Yeah.
Oh God, no. You must not know me very well enough yet.
Well, you do have a 5-day break.
That's true, but chapter 10 starts out with stuff you already know, so it shouldn't take us very long to go through it. Conics.
I don't know what that is.
You know what a parabola is, right? You know how to graph a parabola? Then you can do 10.1.